Eric Greene, and we are going to be talking about Angular and Redux. And this webinar is being brought to you by Wintellect. So before we get started here, let me take a couple of moments to tell you a few things about Wintellect. I've been doing a lot of work now with Wintellect for the past several years, and I can tell you they are a top-notch, outstanding consulting and training organization. When you work with the consultants they offer, they are truly experts in the field in which they work, and they do everything from consulting, literally putting people on your projects and reviewing stuff that you're working on, to providing you training. And their training is outstanding, and I highly, highly recommend that if you have any type of needs for software development consulting, software development training, that you pick up the phone and give them a call, shoot them an email. They'll be more than happy to pair you up with consultants that are really able to answer your questions, give you good direction on how to build and develop software, write code for you, as well as do training, and they train worldwide. So they're happy to send people anywhere in the world to provide the training that you need on the popular technology topics of the day. It could be topics that are more Microsoft-centric, but it could also just be any type of technology, JavaScript, web development, those types of topics, those kinds of topics as well. So I highly encourage you to reach out to them if you need help in any of those areas. So our webinar today is going to be a quick look at using Angular and Redux. We're going to go through a few slides, and then we're going to answer some questions. That we're going to go through a few slides, do some live coding, and then we'll answer some questions at the end. Just so everybody knows, this session is in fact being recorded, and you'll be able to download not only the session but the slides as well as the code at the end of the webinar. The webinar does not really assume that you're an expert at Angular or Redux. If you have a little bit of experience with Angular and a little bit of experience with Redux, it'll definitely help. We're not going to be doing anything too complex. We're basically just going to be taking a look at these two technologies and how you can kind of tie the two of them together to build an application. And we'll talk a little bit about the different problems that they solve. So let's start off first with a quick overview of our first big technology, Angular, and let's talk about what it is. Basically, Angular is an application UI framework. It doesn't solve all the problems of all the layers of a particular application, but Angular, for the most part, solves many of the problems that you would need to solve in building the UI layer part. The languages that we make use of with Angular are HTML, CSS, and JavaScript. Angular is commonly coded with a language called TypeScript, which gets transpiled down to JavaScript. But ultimately, this is a web-based, although it's not limited to the web, a web-based application UI framework using HTML, CSS, and JavaScript. Angular is cross-platform. It can be used for web applications, such as a standard website, what have you. It can be used for desktop applications. You can pair it together with the Electron framework and build desktop apps. You can also use it for native applications through NativeScript, write actual iOS and Android applications with it. Speed and performance. Basically, Angular does the things that you might do if you were building maybe a jQuery website or something like that, but it does it faster. It has a very generalized algorithms for updating pages quickly, maintaining things called view classes and stuff like that to be able to generate pages. It basically takes a lot of great practices and codifies it into a framework that you can use to build your applications. There's a lot of productivity tools that come with it. For example, there's the Angular CLI, which you can use to kind of get up and running. It'll produce a good project structure for you, kind of enforce some good practices for building your Angular applications. A lot of IDEs and editors provide various plugins and other things to support the development of Angular applications. Angular also provides a full development story. I mean, it's got support for testing and animations, and things like accessibility have been baked into it from the ground up. So Angular is really a complete solution to building a UI application, as opposed to other libraries and stuff like maybe React, which only solve one part of the puzzle. Angular kind of solves the whole thing for the most part. When we say a complete framework, what do we mean by that? What we mean is that Angular is more than just simply a component library. It provides mechanisms for providing services, which would be like general purpose code that can be included throughout the application. It provides a module system to help organize your application. These are the types of features that things like React don't really provide out of the box. And so Angular is going to give you that full set of things that you can work with to really architect and build that larger application. Within the context of services, there's very specific services, like, for example, talking to REST services or services that support routing and forms and things like that that are built into the actual core framework. But you can also build your own services, and you can make use of other third-party services as well. For me, the most important part of working with Angular is what I call component-driven development. Now, components in and of themselves are not really anything new in the UI development world. The concept of components have been around for a long time. But within the context of building web applications, components have kind of become all the rage, starting with React and now with Angular, and as well as other JavaScript libraries. The idea of a component is that instead of building some big monolithic UI that has like everything shoved into one big template, which was pretty common with AngularJS applications. By the way, AngularJS was the first version of Angular. When we refer to Angular now, we're talking about version 2 and later. The current version is actually version 4. When you built AngularJS applications, you'd have some big massive template and shove all your UI stuff into that, and it was easy to get up and running, but it really wasn't something that made code really all that reusable or scalable, that kind of thing. With component-driven development, instead of having one big monolithic UI, we actually divide our UI into smaller pieces. And when we divide into smaller pieces, we can then take those pieces and reuse them, and then use them and compose them together to build larger UIs. Understanding component-driven development is really the most important part of understanding how to work with Angular. And what's cool is when we tie it together with Redux, we'll kind of talk to you a little bit about how those two pieces play in together. Let's talk about web components here real quick. Angular sort of supports the web component standards. The support has changed a little bit as the versions of Angular have come out. But the idea of web components is that you can kind of build your own component and drop it onto a web page and then make use of it. There's really 4 W3C specs that pertain to web components: custom elements, HTML imports, templates, and the shadow DOM. Angular components make use of custom elements. They also can make use of the shadow DOM or an emulated shadow DOM. HTML imports really aren't used because we're going to be using ES 2015 modules to kind of tie the parts of our application together, not so much using the HTML import structure. Then we have templates. The concept of templates was originally present in the earlier versions of Angular 2. And the concept is still there, but instead of using the template element per the standards, they now use a new element called ng template, which will display the templates. Nevertheless, the concept of using templates is still a big part of how structural directives work. And so from that respect, Angular tends to be much more closely related to web components as opposed to something like React, which really has nothing to do with web components at all. Finally, cross-platform. We have web browsers, the Electron framework, native applications. You can also do server rendering with Angular and try to build isomorphic type applications as well. So Angular is definitely more than just simply another UI for a simple web page. It can be used on lots of different platforms. Now, one of the problems you run into when working with Angular or working really with any other kind of UI library is the concept of managing state. And what exactly is state? When you think of an application, let's say, for example, I had an application that had a list of colors. So it just managed a list of colors. That application state would be like the list of colors itself. So the actual data that has the array of colors and and then ultimately it gets rendered on the screen. But that data that has the list of colors, that would be the state. But state is also a little bit more than just the list of colors. It could be any other UI information. Let's say I was sorting the list of colors, or I was filtering the list of colors. The values associated with sorting and filtering and that kind of thing, all of that data would also be part of the state. So when we talk about state, we're really talking about a combination of application data as well as UI state information. Well, the problem is, in a lot of applications, developers don't really do a good job of managing this state. For example, let's say I had a data grid, and on my data grid, I was filtering by some particular value on some particular column. Developers would typically store that information inside of the data grid component itself. Well, the problem is, if I'm storing some state inside of the data grid and then other state inside of this other component over here, or maybe I've got a bunch of state in a service, trying to manage and coordinate all of that state across all of the various UI elements on the page can be very problematic. And so while Angular does a lot of things really, really well, it doesn't actually provide a specific concrete solution to this management of state problem. Sure, it provides services and other structures that, if used properly, can absolutely manage the state, but there's no actual formal defined way of doing that. Well, that's where Redux is going to come into the picture. Redux is going to be used to help us manage that application state. So with that said, what is Redux? Redux is a library. It's not a full-blown framework like Angular. In fact, most folks, when they first hear of Redux, they hear about it hear about it in regards to React. So React and Redux is a very popular combination. But even though the names kind of sound similar, they both start with R, they're both 5 letters, the two technologies are not actually formally tied together. Redux can be used with anything. And one of the popular ways in which it's used is actually with Angular applications. And so what you can do is you can take Redux, which manages that application state that I was describing a few moments ago, and it can manage that application state basically kind of outside of the Angular application or even within an Angular service, but definitely outside of the component tree. And it allows us to better understand where that data is being set or being managed and being housed, and then taking that data and updating our component tree with it. All right, so the way to think of it is kind of like this. As you interact with a program and you do one action and then move on to another action and then on to another action, each action produces a new application state. For example, I could be at the login page for an application. I go to the login page, I type in my credentials, I hit login, the server verifies who I am, sends back the necessary information about my account, and then now I'm looking at the dashboard page. I've transitioned from the state of not being logged in to now the state of looking at my dashboard page. And so that state is managed by Redux, and as the user interacts with the application, that state transitions from one state to the other through those user interactions, or what we're going to call actions. Okay? Now, to make this work, we need a single container where we can store this state. And we're going to call this container, we're actually going to call it the store. And what Redux is going to do is going to provide us a library that we can make use of to actually produce a store, and then use that store to hold our state. And then we can take our Angular application, hook into that store to get whatever application state we need, and then we can take that state and then update the UI with it. Now, as you would imagine, because this is a library, there's lots of different ways we could implement code to actually be able to interact with this thing. You can download third-party libraries like NGRX. You can write your own little service to do it if you'd like. What we're going to do is we're going to keep ours very, very simple. We're going to go through the process of basically taking an existing Angular application, and we're going to upgrade it to use Redux. And we're going to take a look at all the little aspects of Redux that you need to make that happen. So Before we do that, though, we need to make sure that we understand some additional information about Redux. First of all, there are three principles of Redux. The principle of the single source of truth, the state is read-only, and changes are made with pure functions. Let's take a quick look at each of those three concepts. So, single source of truth. Redux loosely follows the pattern of what is known as flux. So there's a big long story of something that happened at Facebook in terms of managing application state with multiple MVC patterns that resulted in a lot of chaos and confusion within the Facebook UI about what the current state of the application was in various parts of the UI. And so they came up with this pattern called flux, where basically all actions would travel through this unidirectional flow and would get dispatched to various stores that could then respond to an action and then update the actual component pieces with new information once the action had been processed. Well, the concept of the single source of truth applies to this unidirectional manner. So instead of the components getting information from lots of different components or different parts of the application, they would only get their information from the store. And the store would only update its information based upon an action, and then an action was ultimately triggered by somebody interacting with the UI or through some other asynchronous means. And so you see this unidirectional flow developing where everything basically has this single source of truth. Nothing has basically two bosses. Everything has one boss. And so that simplifies things because you don't have to worry about trying to pull things from different places to update them. It's all kind of handled in one place for you. State. The state can never be mutated when you work with Redux. Basically, you're going to be using immutable programming techniques. What that means is that the state, basically, whenever you have a change to be made, will always produce a new state object. That new state object will then be used to then update the UI. When future changes happen, then a new state will be produced. Well, you might be asking yourself, why is this concept of a new state so important? There's a number of reasons why. A big part is something called change detection. Take, for example, you have an array of 10 items. If you were to add something to that array and then remove something from it, how would you know the array actually changed? You couldn't look at the number of items in the array because you still had the same number of items. You simply added something and removed something. So in order to know something changed, you'd literally have to iterate over all of the items in the array and then compare them and then see if something changed. The problem is maybe for a small array that's not a big deal, but what if you had 10,000 items in your array? That'd be a lot of iterating on every single cycle to try to determine whether or not something changed. When you work with an immutable state and you always produce a new state object, it allows you to compare an object reference to see if something changed as opposed to having to look at all the details. And so when you work with Redux and you produce a new state object on each action, you can then quickly and efficiently update the UI based upon what objects have changed, as opposed to having a change based upon the object reference, memory reference, instead of having to actually go through all the details of the object. Changes are going to be made with pure functions. And we call these reducer functions in Redux. And the idea behind a pure function is that basically the only data that the pure function can make use of is what it receives through inputs, and those inputs cannot be modified. So whatever data you receive through your input parameters, that's the data you work with. Those inputs combined with the algorithm in the reducer produces a single output. So whatever the return statement says, that's what the output of the reducer is going to be. Another part of a pure function is that they produce no side effects. So for example, pure functions don't make AJAX calls. They don't talk to databases or anything like that. They simply take their inputs, run whatever the algorithm is, the business logic, and then yield back some type of result. Now you can take these pure functions and you can use them to compose and build an entire state tree for your application. But these pure functions are the only things that are used to produce a new state object. So if you think about it, we have this unidirectional data flow where the data all flows in one direction. Through the use of actions, reducer functions are used to produce new state objects, and those new state objects are produced immutably, allowing us to easily determine what's changed or not changed so that we can efficiently update our UI. All right, so let's take a quick look here at the definition of Redux. This is from the Redux website. Redux is a predictable state container for JavaScript apps. It's predictable because the state changes are going to follow those three principles. All right. The state itself refers to the application's data, but not just like the list of colors, but other UI-related data as well. The container, all right, Redux is going to be a container, so we're producing this container where these state changes are going to occur using the reducer functions. And Redux is for JavaScript-based applications. So anywhere your JavaScript application can run, whether it's a web browser or an iOS app, what have you, you can make use of Redux. So what we're going to do is we're going to do a little demonstration of integrating these two technologies. I have an existing very simple Angular application, and we're going to go through and build the parts and pieces that we need in order to implement Redux within it. And so we'll take a look at what that looks like. Now, for a real application, are we going to take the approach that we're going to take here? No. You would go and either build your own set of custom services, use like the NGRX library or some other third-party library to build your Angular Redux application. The purpose of this exercise is just to kind of get a good understanding of what Redux is and how you could put it into your Angular application, and then I'll offer a few additional comments on that as we're going through it. So with that said, let's go ahead and get started with this. I'm going to be using Visual Studio Code, and we're using Webpack, and we'll take a look at what this thing's going to do for us. So, like I said, all the code we're going to code here for the webinar is going to be posted up on GitHub, and you can check it out later. So let's go ahead and get started here. So I'm going to take you on a little tour of our application. We have this thing called Color Tool. If I reload the page here, you can see it has a list of colors, and I can type in a new color, so I'll just type in the color black. Click Submit, and you can see black's been added to the list of colors. Let's take a quick look at our application code. So we have the standard set of Angular files here, main, polyfills, vendor. Main is going to connect into our app module here, so there's our app module, all right? And here I've got my app component, and you can see I've got a little template here. To keep things simple, we're just going to be using template literal strings. And I've got my tool header, item list, color form, and then I've got my little app component. And then here you can see where we have our list of colors being managed inside of app component. So this would be an example of managing state inside of a component. We're going to be moving this state out of the component and actually moving it into the Redux store. But we also have a little function here, add color, which will take our new color and add it to our list of colors here. And then we're passing our colors into our item list, and then we have this event handler being passed into our color form. Inside of our components folder over here, we'll start at tool header. You can see it's just a very simple little component that receives some header information and then displays color tool. Very simple item list. We're going to receive our array of items into here, and we're going to receive that as an input through our parameter or through our attribute right here. And then finally, we have color form itself, which is nothing more than just this simple form. We have our new color input, our label input, and then a little button. And then we're going to emit out the new color once you type it in. And so what we want to do is we want to change this application to switch from managing state here inside of app component and actually push that state management out to Redux, and then use app component as kind of a container component. It'll basically connect our Redux store to our other presentational components, things like color form, item list, and tool header, and it'll serve as a container connecting the two of them together. So the first thing we have to do when we want to get started with Redux is we need to think about what actions our system is going to support. When you write a typical web application, You write code for all the different operations you want to perform, but you probably never really think about it in terms of like a list of actions. These are the actions that we can perform on the web application. And so when you work with Flux, and in this case specifically Redux, you want to think about the actions that your system does. In our program right here, the only real action that we're supporting at the moment is the ability to take a color from the color form and then be able to submit that color and add it to the color list, which is what you see down here for the action. So what we're going to do is we're going to go ahead and build ourselves a list of actions that will have one action for adding, and we'll take a look at how to do that here. Now, one of the nice things with working with TypeScript is that I like to use enums to do my action types when I do when I'm using TypeScript. When I'm using plain old JavaScript, I'll just use a regular old object literal with a key value pair. But with TypeScript, we can make use of enums. So we're going to add a new file here. We'll call it action types.ts. There we go. And we'll just export out an enum. So we'll say export enum action types. Perfect. And then we'll simply say add color. So there's our enum that we're going to output there. So this will be our add color action that we're going to implement. Now that we have an add color action, we need to think a little bit about what the structure of our state is going to be. So what's the state again? The state is the actual data that we're going to be interacting with in our application. Not just the data we're displaying, but also things like, what are you sorting and filtering on, that kind of thing as well. So I'm going to come over here to app, and I'm going to create a new file here. So we'll say new file, app-state.ts. And what we're going to do is, because we're using TypeScript, we're going to have to be doing everything strongly typed, which means we're going to have a strongly typed state. So we'll just export out an interface here, and we'll call it app state. And then on app state, we'll just set up our array of colors. If we go back to our original app component TS here, you can see the only real state that we're tracking here is really the colors. If we wanted to, we could move the header value to the state as well. But we're tracking colors here, so our actual colors. And so there's our array. So we're going to set up our state over here to have colors. Once we have our state configured, we need to start thinking about how we're going to be processing this state using reducer functions and how we're going to be creating our actions. So what we're going to do is we're going to come over here to app, and we're going to create two folders. We'll create a new folder called actions, and we'll create another new folder called reducers. Now, before we can write a reducer, we actually need to have an action that we can generate. So we'll go ahead and work on the action part first, and then we'll come back and take a look at how to make use of that action in the reducer, which would then produce the new state object. So I'll come into actions here, and I'm going to create a new file, and we're going to call it color actions. Now you could imagine in a real application where you have a large amount of state, you'd have many types of actions, many types of action files, that kind of thing. But for our very simple focused application here, we'll just create a file called color actions. Now, the first thing we're going to have to do is import the actual action type from Redux. One nice thing about Redux is it actually comes with all of these types built into it. So if you're using TypeScript or Flow, what have you, these types are already present for you to be able to make use of. This is not the case with other libraries. If you were using, for example, something like React, you have to import those types as a separate thing. If you're doing core.js, you have to pull in those types as a separate thing. But with Redux, it comes with, comes basically batteries included, and it's got support for our typing system here. Now, in addition to pulling in action, we're going to have to pull in our actual action types that we defined a few moments ago with our enum. So I'm going to say import, and we'll say action types from ... action types. There we go. So there's our action types. Now the first thing we're going to have to do is we're going to have to create a strongly typed action. You know, a lot of these steps we would not be doing, obviously, if this was just plain old JavaScript, because we wouldn't have to deal with all the strong typing. But if you're using TypeScript, you have to take that into account, and so things like your state and your actions will actually be strongly typed. So we'll come into here, we're going to define ourselves a new interface, and we're going to create a color action type. So this will be used for any of our actions that pertain to colors, and it's going to extend from action. On the actual action type, you will see, if we go to the actual definition here, you'll see that on the interface provided by Redux, there's a type property. Every action in the Redux, whether it's TypeScript or JavaScript or what have you, every action that you send into the Redux store has to have a type property that tells you what action type it is. If there is no type property, Redux will actually give you an error and complain. So with TypeScript, we are actually going to make this strongly typed, so we have our actual action type. And we're going to extend that, though, because in addition to the type being defined on the action, we also have the ability to define any data which is going to be used to then update the state. So we can come into here and say color, string, and this is going to support our use of the color action to actually add a new color to the array of colors. So our new color is going to be stored on this color property for our action object that implements this particular interface. So now that we have this color action interface, we now need to create a special kind of function called an action creator. What this special function is going to do is it's going to allow us to easily create the action object in the shape that it needs to be. Okay? So we'll come into here and we'll say export const add color, and then we'll say color string, and this is going to be the actual new color that we're typing, and we'll pass into there. All right, there we go. So now we're going to have to define some type of return type. The return type is going to be the color action interface that we defined above. So now we'll come into here and we'll actually say color, and we'll do ourselves a little object literal here inside of parentheses, and we'll go ahead and define our type. So we're going to say action types dot add color. One nice thing about working with TypeScript and Visual Studio Code is you get some awesome IntelliSense. And now we're going to come in here and say color. And so what this is going to produce for us is basically an action object that will have a type property for adding a color, as well as an actual the actual color value that's going to be used to add to the actual list. So now we have our add color action creator. Once we have this, we now need to turn our attention to actually producing our reducer function. Remember, the goal of our reducer function is to take this action and produce a new state object from it. So let's go ahead now and set that up here. So we're going to come over to reducers, and we'll create a new file, and we're going to call this color reducer.ts. So there's our color reducer. Now this file is going to be a little bit more involved. We're going to have to pull in a couple of different things that we've already created, as well as pull in the reducer type from Redux, and then we're going to produce our function. So the first thing we're going to do is say import reducer from Redux. There we go. And then we're going to have to pull in a couple of other things we've already created. For example, we're going to have to pull in our app state interface. This is because the reducer is going to want a strongly typed application state. So we'll say import from app state. We're also going to have to pull in our color action that we just defined a few moments ago. In fact, actually, it's not saved here at the moment. Let's make sure I save that. Now back to color reducer. So color action, so we have our strongly typed action there, and we're going to say from, and then we'll do actions slash color dash actions. There we go. And then the last thing we'll pull in is the actual action types that we defined at the beginning of the little code demo. So we'll say import action types from // action dash types. Excellent, there we go. So we have our three things pulled in that we're going to need to build this reducer. Next thing we need to do is actually define the function. So we'll say export const, and we'll say color reducer, so we'll give it a name, color reducer. And this will be of type reducer. This is going to be a generic type, so we'll come in and specify app state. All right, so now we have our strongly typed reducer function. And then we're going to come in and actually define our actual function itself. So first thing that a reducer function is going to receive is going to receive whatever the current state is. That will be the first parameter, the first argument passed into it. So we'll say state, and of course this is going to be of type app state, which we defined above. Okay. And here we can actually do a one-time initialization of our state if our state happens to be undefined when the reducer is fired up. So what we're going to do is we're going to say colors like that, and I'm going to copy the original data that we had hard-coded over here, and we'll take that right there and come back over to our reducer, and we're going to initialize this just like this. Now, in a real application, you wouldn't hard code a whole array of values like this. Instead, you'd pull data from the database or something like that, and it would be more dynamic. But for just keeping things simple to understand what Redux is doing here for us, we're going to hard code this initial value here. All right, so after we set up that, then we need to set up our action. So we'll say action, and of course the type for this is going to be color action. There we go. All right. And there we'll put our little comma in. Awesome. So now we need to actually implement the function itself. So we've got the parameter definition taken care of, but now we need to actually implement the function. So we'll come into here and we'll do that, and now we have an actual function body. Now, there's lots of ways you could implement this function body. A lot of different thoughts and theories and suggestions on how to do this. I'm going to use the most straightforward approach for what we're doing here in this webinar. This is not necessarily how I would do it for a real application. Nevertheless, it works perfectly fine, and there's nothing wrong with using this approach. So what we're going to do is we're going to set this up so that when we receive an action, we want to have a way to figure out what type it is and then have some code that will do some processing of it. The simplest way to represent that for this webinar is to use a switch statement. Now, for my true functional programming friends out there, you're going to probably question why I would use a switch statement here as opposed to other more functional methods. Other more functional methods would probably be more appropriate for a real application. But to simply introduce the concept on logic of what a reducer does, the switch statement works perfectly. So we have a switch statement here, and we're going to say case action types dot add color. So we're going to be looking for this particular action type. For right now, I'm going to put a return statement, and we're going to come back to the actual action type here in a moment. But I want to talk about this other case we're going to put in called default. We're going to literally say return state. One of the things that your reducer has to be able to do is that if it receives an action that it doesn't care about, it can't simply ignore that action and do nothing. It actually has to return the original state object that was passed in as an argument. So the reducer can choose to not make any changes or not produce a new state object, but it can't choose to simply ignore it and return nothing. If your reducer returns nothing, you will lose all of that state, basically. And Redux will just think that there's nothing being returned. The state object has basically just been wiped out. So you always have to make sure that you return something from this reducer function, and that is either going to be a new state if you did create something new, or it will be the original state, which we have set up here for default. So now we're going to go ahead and implement add color here. And there are several ways we can do this. We're going to take an approach of using the spread operator to do this, but you could also use object.assign if you're more familiar with that approach. So what we're going to do is we'll come into here and we'll say return, and we're going to take the original state and we're going to spread it out over this new object that we're creating. So all the properties on the state are going to be spread out over this object. But what we want to do is we want to update one of those particular properties, in this case colors, with the new actual color values. So we'll say colors. And then we're going to use our array syntax here. And inside of here, we're going to spread out the state.colors. So we're going to spread out the array of colors into this new array structure. And then we're going to take the new color that we're adding, action.color, and place it here. So this is using the spread operator to actually produce a new state object that will have a new updated colors property, which points to a new array. You'll notice we're not mutating anything here. At no point are we mutating the object that the state variable points to. We're not mutating the actual array of colors that state.colors points to. What we're doing is producing a new object, copying the original properties over from state, replacing one of those properties with a new property for colors, and then taking the original array of colors and producing a new array with it, and then adding this new color to the end of that new array. So all of our code here is working in an immutable fashion using this syntax here to make it more expressive. You could have also done this with object.assign. In fact, just for fun here real quick, you could have written the code like this. You could have said return object.assign, produced your new object, copied over all the properties from your state, and then you could have done something like this where you have colors and then done state.colors.concat, and then we could have said action.color. You could have also done that as well. You can see, though, my TS-lint here is actually complaining. It says use the object spread operator instead. So my linting rules are basically telling me not to take this approach, but instead to take this approach instead down here on line 15. But we'll comment that out just so you can see that as an example. There we go. And then we have our reducer coded over here. So now that we have this reducer coded, now we need to actually build our store. So we've got our action creator, our action types, we've got our reducer. Now we need to produce the store that all of this state is going to be stored inside of. So to do that, we're going to create a new file over here called app-store. We'll put that right inside of our app folder here. So we'll say new file, app-store.ts. And then inside of here, we're going to go ahead and import the create store function from Redux. There we go. Then we're going to pull in our app state because it'll be a strongly typed store. We'll also pull in our color reducer so we can make use of that when producing the store, and that will register our reducer function. So we'll say import app state from app state, so that'll pull in our interface. Then we're going to say import color reducer from, and we'll pull that in from our reducers. There we go right there. So there we go, so we have that. So now what we got to do is actually produce the store itself. So we'll say export const, and I like to call my store app store. There we go. And we'll say create store here. There's our create store. We're going to pass in our app state interface type there. And then we'll simply say color reducer like that. Great. So now at this point, I've got my store being created, app store. It's got the reducer. Okay. When create store runs, it'll run that color reducer the first time, initializing our state to be the array of colors. Now what we need to do is actually use this in our actual Angular application. So we have the two different pieces now. We have Redux and we have Angular. How do we tie the two of them together? There are several ways you can do this. We are going to do a very, very simplistic way of doing it. But if you were doing this for real, you would want to build a service, maybe use a third-party service, what have you. But we're gonna do this. We're gonna do this directly here inside of our app component. And so we're going to pull Redux into here and be able to make use of it. Okay, so to do that, we'll have to pull in a couple of different pieces. First of all, we're going to need to pull in the store type. We're going to set up the store as actually as a property on our component so that we can tie it together with our presentational components, tool header, item list, and color form. So up here at the top, we're going to say import and we'll say store from Redux. There we go. And then we're going to have to pull in our app state, our actual app store that we created, as well as our add color action creator. So we'll come into here, and we're going to say import app state from, and then we'll do our app state here. Next, we'll pull in that app store we just created, app store from /app-store. Then finally, import add color from /action/color actions. There we go. Okay, so we have the different pieces and parts we need. Now we need to incorporate this into our component. So down here, the first thing we're going to do is we're actually going to get rid of a couple of things. We'll get rid of that. We don't need those now that we have those child components. We can also get rid of colors. We're not going to be managing the state of colors anymore inside of our app component. Instead, we're going to be using our Redux store. So we'll come into here and we're going to create a new property. We'll say public app store. This will be of type store. And then we'll pass in our app state type. So we'll have a strongly typed store. And we're going to set this equal to the app store that's being imported here. So up here at the top, we imported app store, and we'll just assign that reference right here. Okay. Now we need to reference this app store for both adding the color as well as displaying the colors. So what we can do is come into here and do the following. We can come in and say app store dot get state dot colors. So a Redux store comes with a function called getState, which will basically allow us to retrieve whatever the current state is at the moment, and then off that state we can reference whatever properties we have. In this case, we have a colors property with this colors array. So we've imported that. We're going to pass that directly into our item list. Down here we now need to make use of our app store to actually update. So to do that, we'll come into here, and we're going to say app store dot dispatch. So dispatch is the mechanism by which we take an action and actually dispatch it to our store, and it'll be processed by our reducers. So we'll say app store dot dispatch, and then into that we're going to call our add color function here, producing our action object. So we'll say add color, and then we'll take our new color being passed in here via our parameter. So we'll say new color like that. There we go. So it doesn't look like we've done a whole lot here. That's because it is a relatively simple application, but we have actually done something quite profound. We've basically removed the application state, such as the color list, from the component tree itself and placed it into this other location. And then this other location is going to receive actions, update that state, and then pass that state back into our component so that it's displayed on the screen here. So we're going to go ahead and save that. There we go. We'll head back over to our web browser, and you'll see there's our application loaded up. And we'll go back and try to add black again. And assuming we didn't make any typos along the way, we should be able to click Submit Color, and then black shows up in the list. So now our Redux store is actually storing our state, instead of storing that state in this component or really in any other components. Now, this app component has a special name. It's what we would call a container component. The app component itself isn't primarily interested with how the UI stuff is actually done. It's really more interested in connecting this application store up to our UI components. You'll notice in order to make this work, we didn't have to change anything in tool header or item list or color form, because these have no concept of where the state comes from. It just knows that they received the state through the various input values that are passed in through the attributes. And then of course in the case of color form, it outputs whatever the collected value is, and then that collected value is then dispatched to the application store so that we can add the color. So the nice thing about this approach of a container component like app component versus presentational components like color or like a color form or item list is that color form and item list could be reused across the board in any number of applications, whether they used Redux or not. They don't have to be hooked into Redux to operate properly. However, app component is specifically designed to work with Redux because it's for this particular application, and it then connects into these presentational components using the ordinary means by which data would be shared in an Angular application. So what are some additional ways we could change this structure and design? We could take this entire App Store process here and we could move that out to an Angular service. We could then inject it into this component using Angular's dependency injection mechanism and make use of it that way. We could use another service like NGRX, which kind of combines using Redux and RxJS to tie your application together using observables and other reactive programming techniques. You could use that if you'd like. The key, though, at the end of the day is this. No matter what method of implementation you choose to use, you need to make sure that A, your state is truly being managed outside of your application. The only real exception to that would be like maybe collecting data off of an input field. For example, you'll see here for my color form, I'm still tracking the data from typing into the box off of this property. I don't really consider that to be like the application state. I consider this to just be nothing more than a convenience variable to allow me to use ngModel to capture the data before I then ultimately submit it back out. But the ideas we want to keep in mind is that the application state, with very few exceptions, is completely managed by Redux. That means every part of the application gets its state from one place. And then the way we tie that application state into the application is through something called a container component that doesn't focus on UI, but instead focuses on how to talk to Redux, no matter whether that's through a service, through a service ucode, or another third-party service, what have you. And then finally, the presentational component that's not locked into any specific way of how the state's managed. It just works with the input that comes in. If you follow those principles with Redux, while your implementations may vary, you will build an application that is easily extendable, maintainable, with components that are truly reusable, and in an application state that's very, very easy to understand and follow, really no matter the size of the application itself. Okay, so that concludes our little demonstration. Like I said, all the code will be pushed up to GitHub. It's time now to go ahead and answer any questions that we have. Here's, by the way, here's the link to the GitHub repo that I have here. I think there'll also be a secondary GitHub repo as well. But I'll push the code up to here. You can check it out there or check it out on the other one as well. And then I have my email address. You're always welcome to send me questions via email after the webinar is over. But we've got about 7 or 8 minutes left here, and I can even go a little past 2 p.m. Eastern Time or 3 p.m. Eastern Time and answer whatever questions you have. So let's go ahead and open it up to questions. I'm going to come over to our question section here and see if we have any questions. Let's see here. Do we have any questions? Does anybody have any questions? Let's see. All right, it doesn't look like we actually have any questions unless I'm missing something here, but I don't think I am. Let's see here. Okay, well, let's do this then. Since we don't have any questions, let me offer. Let's go ahead and do this. We don't have any questions. Let's go ahead and write a little bit more code here. So one of the things we can do is actually move this thing to a service. So let's write some code to go ahead and do that real quick, and we'll use up the remaining 5 minutes of time that we have here before we take off. So if I wanted to move this thing, here's a question from David. Will Apple sue you for using the variable name App Store? I certainly hope not. I certainly hope not. Let's go ahead and code up this thing as a service real quick since we don't really have any questions, and you guys can see what that would look like. So I'm going to come under app here. I'm going to create a new, not a new file, we'll create a new folder here. We'll call it services. There we go. And what we can do is come into here, we'll just create a very simple service. Like I said, there's lots of ways you can code this. We'll call this our App Store .service.ts. And we'll come into here and we'll say import injectable from @Angular core. There we go. And we'll go ahead and export ourselves a class here. We'll just call this our App Store service at the risk of being sued by Apple. We'll call it our App Store service. And we'll say @injectable. There we go. And then here on our little App Store service, we are going to set this up so that we will just have a way of getting our store, initializing our store, getting our store, that kind of thing. So we'll set up a little constructor here. And what we're going to do is we'll grab our App Store here. We're going to take our App Store code. We'll just grab that whole piece of code right there. And we'll come over to our service. And we'll drop some code into here. So we're going to take our create store, pull that out, pop that in there like that, pull these two out here as well. All right, so there we go. Now, we're going to take our App Store and we'll say this.appstore. There we go. Okay, so we'll need to define App Store on our actual service here. So we'll say private App Store. And of course, this will be of type store. So we'll do store here. And we'll say store. And then we'll type in our app state to be our actual type. So there's our store right there. Okay, so we're going to create our store when our service is created. Looking good so far. Now, we can, of course, we could make the App Store publicly accessible, or we could build in various little helper functions. So, for example, we could build our own little get state function here if you want to. We'll just make it a little wrapper. We can say return this.appstore.getState. And we could also do something along the lines of public. In fact, actually, let's make it a little more specialized. We'll say colors. And then we'll say getState.colors. And then we'll come down here and we'll do one for our add color action. There we go. So now what we're going to do is we're going to kind of hide behind this little service interface the ability to get the colors as well as to do the add color operation. So for this, we'll say this.appstore.dispatch, and then we'll come back over to our app component and we'll import our add color. There we go. And that will need to go up a folder, up a folder, up a folder. And then now we'll come in here to our dispatch and we'll say add color down here. And then, of course, we can pass in our new color here as a string. There we go. And we'll take new color right here, pop that in like this, boom. So now I have the ability to dispatch my new color that I'm adding. Okay, so far so good. And let's see here, it's complaining. For whatever reason, Visual Studio Code does this weird thing where it complains about experimental decorators, even though our tsconfig file has it set up properly. Sometimes I find that if I come into here and actually just close my file out and then reopen it, the error will sometimes go away. It looks like it's not doing that in this case. Okay, so there we go. So we have injectable, we have our injectable there, and we have our App Store. Now we need to register our App Store with our module down here. So we'll come into here and we're going to say import App Store from, And this will come from services / app-store .service. There we go. And then I'll take my App Store and I'm going to register it with my providers. So we'll say providers, boom. Okay, so there's my App Store. Now what I want to do is I want to come back over to my component and I'm going to add a constructor to this. I can actually get rid of all of that there and this, and I can just simply import my App Store from, and then we'll say / services app-store.service, boom. And then I'm going to take App Store here, and we're going to set this up to be injected via our constructor. And we'll say private App Store, and we'll specify our type there. Okay, so there's our App Store coming in. And then what we're going to do is we will take our App Store here. We'll say this.appstore, and we're going to dispatch our, we'll actually just say add color right here. Boom, boom. So now we've got this.appstore.addColor new color. And then the last thing we'll do is take our App Store and change that to get colors. And that'll just simply return back our colors to us. So now we have our item list, all that working through the new service that we're making use of. And we have our add color down here. So we should be able to save that. Let's reload our code here. Let's see if we got a little bug. App Store get color is not a function. Did I say get color or get colors? Make sure you pluralize that. Save it. Come back into here. You can see we have our colors showing up. I'll come in and add black. You can say submit color, and now black is added. So what we did was we simply took that service that we had previously implemented directly in our component, and now we just moved it out to its own service and then allowing it to be included that way. And of course, you could take this service here and you could start to extend this out lots of different ways. You could put very specific functionality like I did here. You could make it more generalized. But you have a lot of control over how you want to implement this. The key, though, is to make sure that the application state is in the store. The store is connected to the presentational components via a container. And then the presentational components receive their inputs through the usual means of Angular components or any framework or library you're using. And they don't have any actual direct knowledge of the Redux store itself. Okay, cool. So hopefully that little demonstration answered some people's questions. And let's see. All right, so we have one question here. State is a singleton to the whole application with the service. Yeah, so state, there's only one state object for the whole application. The whole application object, the whole state is stored in one state object in one state tree. And so if we use our services as a singleton, as you know in Angular 2 and later, you can have multiple instances of services, but in this case you'd want to have a single instance of your service, and in that single store service that you would create, the state would be housed in there inside the store. And then you could use that all throughout the application, but the entire thing would all be in that one state tree, the entire state for the application. Okay, very cool. Well, if we don't have any more questions here, actually, we've got another question here. Awesome. Okay. How big can the state become? It can become massive. On some of the consulting jobs that I've been on and some of the applications that I've written, but especially some of the consulting jobs I've been on, people have had very, very massive state. I mean, it's huge. They have everything. And in some cases, they even track all of the user input keystroke by keystroke on the state itself. I've known of cases where people have hundreds or thousands of reducer functions to update various parts of the state tree. So the state can be really, really large, and it's really amazing just at how fast JavaScript can process an action being handled by all of those reducer functions. It really is amazing. So, so you definitely don't want to have two states, because then that kind of defeats the whole single source of truth. Within the concept of the state being a single source of truth, as well as having one single unidirectional data flow where each part of the data flow is a single source of truth for the next part of the data flow. All right, so dovetailing off of that last question about the size of the state, sure, the browser's memory does get consumed. What I have found is that the browser's memory never really gets as filled up as I think it's going to get filled up. You know, depending upon truly how much data you have on your state, it may not be as big as you really think it's going to be. Obviously, there's always limitations. I mean, if you had, you know, a state tree that had 1 million objects, and each of those 1 million objects had a property within 1 million items inside of an array, that might start to be a problem. But as long as you're not doing anything too crazy, you shouldn't have any problems with the actual browser's memory. Now, of course, if your application has to run on older equipment, older hardware, older browsers, who knows? You might possibly have performance issues. But in the places I've worked with, it's been quite amazing, just really the performance and even the memory performance you get in terms of working with Redux. And the thing about it too is that, you know, it's not just about the memory and performance, although that's super important. It's also about the developer being able to maintain such a large application and understanding the data flow. That too is also super important. And Redux really does simplify things. It can be a lot of coding, don't get me wrong. It can definitely feel like a lot of coding, but it makes things easier to understand and manage over the long haul. Okay, awesome. Well, I think that concludes all the questions and concludes our little demonstration here. Like I said, the code we made available to you, you can go back and watch the webinar later. And for anyone who's interested, who's still with us, you can, of course, email me at my email address here with any questions you have about Angular, Redux. I do a lot of stuff with React, a lot of stuff with JavaScript in general. Always happy to hear from folks. And I'd be more than happy to, or feel free to reach out to me. I'm more than happy to answer any additional questions you have. Okay, well, that's it. You guys have an awesome day, and thank you everybody who made it out to the webinar. I really appreciate it.